Today's notes are on multi-step inequalities and special cases. It says, for each of the following problems, solve the inequality drawn on a number line and write your answer in interval notation. We've been doing stuff like this. It's just now we're going to be doing multi-step, so it's going to take a little bit longer. Process is still the same though. First step is to try to combine all terms, like terms on the left and on the right. There is nothing to combine, so I'm going to go ahead and get rid of the smaller x. In this case, the smaller x is the 4x, so let me go ahead and get rid of the 4x on both sides. These are going to cancel. I'm left with 10. Since I'm subtracting, I'm not going to change that sign. It's going to stay as a 2x minus 24. And now I just need to undo what's being done to the x. I'm going to group up the 2x, and I realize that it's being subtracted by 24. So I'm going to add 24 to both sides. These are going to cancel. I get 34 is greater than 2x. And then I realize that the x is being multiplied by 2. So to get rid of that, I'm going to divide both sides by 2. I do not need to change the direction of the symbol here because I'm dividing by a positive number, and that is okay. 34 divided by 2 is 17, is greater than. These are going to cancel, and I'm left with an x. Now remember what I said about these types of problems. I don't like it when the variable's on the right-hand side, so at this point, I'm going to reverse this entire thing just to make it easier for me to graph, because students tend to make mistakes when the variable's on the right. So I'm going to reverse the entire thing. Instead of saying 17 is greater than x, I'm going to say the exact opposite. I'm going to say x is less than 17, and that's really saying the exact same thing, okay? I'm not changing, I'm just changing the way it looks, but it really is saying the exact same thing. So I know my x is less than 17. They said to go ahead and solve the inequality. There it is. This is my first answer. Second answer is to draw it on a number line. Hey, your number line should be really quick. Like, I don't want you spending forever making all these tick marks. We're just going to put 17 in the middle of my number line. I'm going to go a couple of numbers above it, 18 and 19. I'm going to go a couple of numbers below it, 16 and 15. We're going to circle the boundary point. Since there is no equal sign underneath the 17, we don't shade it. And I want the numbers that are less than 17, like 16 and 15. That's going this way. I'm done with my number line. And then the next thing I need to do is I need to write it as an inequality. Always start from the left side and then go to the right, okay? So where did my inequality start? It started at negative infinity. Please don't forget that negative. And it goes all the way up to 17. Infinities always have parentheses, and because the 17 is not shaded, I'm going to leave this in parentheses. And that takes care of my first problem. Let's go ahead and move on to the next problem. I got negative 2x plus 1 is less than 4 plus 4x. Remember, in this case, we're going to distribute the negative. Now, this one is a little bit tricky because when I distribute the negative, some of us are going to think, oh, I'm multiplying by a negative, so I need to go ahead and switch the sign. But that's only when you multiply both sides by a negative. And in this case, I'm only distributing on the left side. So we get to keep it with the same direction, okay? Now that I have this, there's nothing to combine. I'm going to get rid of my smaller x. My smaller x is a negative 2x. I get rid of a negative 2x with a positive 2x. These are going to cancel. I'm left with negative 2 is less than 4 plus 6x. To get rid of that, I notice that the 6x is being added by 4, so I'm going to subtract 4 on both sides. These are going to cancel. I'm left with the negative 6. We keep the same inequality symbol. And then here, I realize that the x is being multiplied by 6, so I'm going to divide by 6. Again, I'm dividing by a positive 6. That means I do not need to change the symbol on the inequality sign. Negative 6 divided by 6 is negative 1. I'm going to keep that same inequality. And just like before, I have the x on the right-hand side. Since the x is on the right, I don't like that. I'm going to go ahead and reverse it. So when I reverse it, I get the exact opposite. So I put the x in the front, I change the symbol, and I put the negative 1 in the back. I want my x's to be greater than negative 1. I'm going to draw a number line really quick. Negative 1 is in the middle. I want two numbers that are bigger than negative 1, like 0 and 1. I want two numbers that are less than negative 1, like negative 2 and negative 3. I'm going to circle my boundary point. I'm going to circle negative 1. And this is saying I want the x's that are greater than negative 1, like 0, 1, 2, and 3. So there's my first answer is the inequality. My second answer is the number line. Third answer, I'm going to write this in interval notation. Always start from the left and go to the right. So my graph started at negative 1 and it ended at positive infinity. I'm going to put a parentheses on the negative one because it's not shaded in, and always, always, always a parentheses on the infinities. All right, and we're down to our last one. Let's see. I'm going to try to combine whatever I can combine. It looks like I can combine the 7x with the minus 4x. So let's go ahead and combine those first. I get x over negative 3 plus 5 is greater than or equal to 7x minus 4x is going to give me a positive 3x minus 5. Here, I would love to move my x's over, but when I do that, I'm going to get a fraction. And I don't like that. So instead, what I'm going to do is I'm going to multiply and clear that fraction. I'm going to multiply the entire left side by negative 3. And I'm going to multiply the entire right side by negative 3. Hey, I multiplied the left and the right by a negative number. That means that inequality needs to change directions like this, okay? Because again, when I multiply by a negative number on both sides, that inequality needs to change, okay? All right, what happens when I distribute this negative 3? Well, here, the negative 3 is going to cancel with the negative 3. That's great. That's going to leave me an x. When I distribute it here, negative 3 times 5, that's going to give me a negative 15. Is less than or equal to, when I multiply this side, negative 3 times 3x, that's going to give me a negative 9x. And then negative 3 times negative 5, that's going to give me a positive 15. I'm going to go ahead and get rid of the smaller x. In this case, the smaller x is at negative 9x. So I'm going to add 9x to both sides. These are going to cancel. I'm left with 10x minus 15 is less than or equal to 15. We're going to add 15 to both sides. These are going to cancel. I'm left with 10x is less than or equal to 30. Divide both sides by 10. These are going to cancel. I'm left with x is less than or equal to 3. Again, really quickly, number line. Here's my 3. I want two numbers bigger than 3. I want two numbers less than 3. I'm going to circle the 3 because it's my boundary point. I need the x's that are less than or equal to 3, so I'm going to go this way. And because I want that equal sign, I need to shade in the 3. Remember so here's my first answer, I have my inequality. Here's my second answer, I have my number line. And then my third answer is going to be, how do I describe this number line? Remember, you start from the left and go right. So this graph is starting at negative infinity and it's stopping at 3. Negative infinity has a parenthesis because it's an infinity. 3 this time has a bracket because there's an equal sign or it is shaded in, okay? So that takes care of how to solve multi-step problems. Let's go into some special cases that we're going to experience and see how this looks like. There are going to be times when solving inequalities that the variable disappears. These are special cases that have their own type of solution. So on these special cases, I'm going to go ahead and highlight this right here. Special cases. If you get a true statement, actually, let me go ahead and do this one in green because it's true. If you get a true statement is going to look like something like this. Something where it says like 0 is less than 4, and you go, well, of course 0 is less than 4. What this is implying is that all the numbers for x will always make this inequality true. In this case, we say that our solution is all real numbers. That is to say, every single number is going to make that inequality true. A really quick example of this is like if I have x is less than x plus 2, every single number that you pick for x, every single one, this side will always be smaller than this side. Why? Well, because this is x, and then this is 2 more than that. So like if x is 5, then this is going to be 5, and this is going to be 7. Well, yeah, that worked. If you picked a different number, like 10, well, this is going to be 12. This side's always going to be bigger. Always. Doesn't matter what x you pick because you're adding 2 to it. Okay? So every single real number is going to work. And since every single real number is going to work on a number line, we're going to write it from negative infinity to infinity. Because again, on a number line, we're shading in all the answers that work, and I'm telling you all the answers work. And so the graph starts at negative infinity and it ends at positive infinity. So we write it like that. Okay? All right, as far as case number 2, what's the opposite of getting a true statement? Well, the opposite would be getting a false statement. A statement like that would be something that looks like this. They're going to tell you something like, oh, 2 is greater than 5. And you're going to say 2 is not greater than 5. There's no way that works. They're telling you that the inequality is going to work when 2 is bigger than 5 and 2 is never bigger than 5. So you're going to get no solutions. So what I'm saying is this is implying that there is no numbers for x that will make the inequality true. In this case, we say that there is no solution. It's never going to work. It's almost like going to say, hey, how many years are you going to be older than me? Well, you're never going to be older than me. Not in 2 years, not in 5 years, but pretending that nobody dies, right? Um, not in 100 years, you're still not going to be older than me. Okay, so it doesn't matter what x you pick, it's not going to work. And for this interval notation, you would write either this little squiggly bracket with the null set. We put a circle with a line through it, or we can just write no solution. Both of them works. Let me go ahead and highlight that as well. No solution. Actually, I forgot. We should highlight this one and this one. And you should also highlight this one over here. All right, let's see what this is going to look like because I'm sure you're curious going, what are you talking about? But you'll see how this works. I got negative 4 times 3x minus 1. We're going to go ahead and distribute this negative 4. Notice that I'm only distributing on the left-hand side. So I'm not going to change the symbol. This is going to be negative 12x plus 4 is greater than negative 12x plus 5. I'm going to go ahead and get rid of the smaller x. So I'm going to add 12x to both sides. When I do that, I get 4. These are actually going to cancel. 2 is greater than 5. Hey, is 4 greater than 5? This is false. So on a number line, like if you were to set up a number line, you would draw it like this. Let's just do a couple. 0, 1, 2. And remember, when you draw a number line, you're going to draw all your solutions. I don't have any solutions, so we leave it blank. Okay, on your number line, you're just going to leave it completely blank, and we can just write no solution as our answer. You can also do the empty set. I'm going to go with no solution. I think that one's a little bit cleaner. All right, so let's look into the next one. I'm going to take that 2 and I'm going to distribute it. I get 2x minus 10 is less than 2x plus 5. I'm going to go ahead and get rid of the smaller x. In this case, I'm going to subtract 2x on each side. These are going to cancel. I get negative 10. Actually, we're going to keep that same symbol. These are going to cancel too. Negative 10 is less than 5. When is negative 10 less than 5? That's always true. Notice that I don't have any x's, right? It's completely gone. I don't know why I did that. Let me go ahead and, nope, we're going to leave it like that. It's fine. Negative 10 is it's less than 5. I don't know why I have that TRUE like that. We're going to go ahead and draw my number line. Hey, negative 10 is always less than 5. So when I do my number line like this, every single number is going to work. So what am I going to shade in? I'm going to shade in all of it, all of it, all of it. So every single real number works. And so now when I do my graph, where did it start? Well, this thing started at negative infinity. Where did it end? Well, this thing ended at positive infinity. My interval notation is going to go from negative infinity to positive infinity, which basically covers every single number possible. Okay. Hopefully this is making a little bit more sense now. Let me go ahead and move this a little bit over to the side to give myself more space. All right, we're down to our last one. Let's go ahead and take that 2 and distribute it. I got 6x plus 10 is less than or equal to, and I can combine the 4x with the 2x. That's going to give me a 6x minus 3. I'm going to subtract 6x on each side. These are going to cancel. These are also going to cancel. I'm going to be left with a 10 is less than or equal to negative 3. Is 10 less than or equal to negative 3? Absolutely not. This is false. So when is this going to work? It's never going to work because 10 is never going to be less than or equal to negative 3. So since this never works, then I'm never going to get an answer on my number line. My number line is going to be just completely blank. I'm going to put 0 here, 1 and 2, negative 1, negative 2. We're going to leave it completely blank because there are no solutions that work. And then as far as writing it in interval notation, you can either use the empty set like this, or you can also write no solution. Both of those are the same thing. All right, hopefully that makes sense. Understand the difference between this one, right, when you don't have any x's, And this one, when you do, like, oh, I know what my solution is when the x's are less than or equal to 3. Okay. It is a difference. On some of them, you're going to have x's. On other cases, you're not going to have any x's, and you're going to need to know what that means. All right, guys, that's all the notes for today. If you have any questions, as always, please feel free to ask.